So today we're going to be talking about magnets. And I really like magnets. A lot of my friends really like magnets. My girlfriend really liked magnets. I got her a magnet birthday present. And they're very interesting. So let's go on to the basics. They have a north and a south pole. Okay? Two poles. I'm going to put two poles. Okay? And then the field goes from north to south. So that's pretty easy to see on the outside. And it goes from north to south, and that's all you need to do is memorize, and it looks kind of like this. But on the inside, it looks like it's going from south to north. But the thing is, you have to remember that if we divide it, it becomes north to south. So if we keep dividing it, each of these dividers would be sending it this way. Okay? But easy way, probably the best way to remember is on the outside, north to south, on the outside. And that's pretty much what you'll be basically using. But I remember I got confused for a little while. So it's south to north on the inside. No, that's not technically correct because it's still north to south, but it just looks like it's south to north. Okay. What else do you need to know about these? These fields are vectors. So what is a vector? So these are all vectors. It has a length and a direction. Okay? So the thing about vectors is you can add them together. If I wanted to add this and this, how would I add them together? We just put them together. That would be the field. Okay? This would be the field. So if I told you we had two bar magnets sending single fields out like this, then the resulting field would be that. You see? Because we just put them together. Now, if I change this bottom one to a south-north, then this one would be coming out like this, and this would be going in. So our resultant vector, or our final net field, would be that direction. Okay? Make sense? I think we can try some questions then. Yeah, let's try some questions. So, here's a bar magnet. Complete the diagram by sketching 5 magnetic field lines around the magnet. You must include arrows which show the direction of the magnetic field. So easy. Probably the best things to note are it goes out straight, and it comes in straight, and it does all these other lines around here. And so remember, it's always going from north to south, or coming out of north, going towards south. So that's how you draw it. Complete the diagram by sketching around the magnets. You must include arrows which show the magnets. So, when we have two souths, I'll show you in a second. First I'll draw this line going out here, and I'll draw this line going out here. Now the lines going out here are pushing away from each other. Okay? Remember they're going in. But because they're both south, because they're both going in, they don't go into each other, like up here. You can't go from north to south. Here it's the south against the south. So they bend around each other. And I think that kind of makes sense. I think you kind of know what you're doing. I'm just going to draw these lines. Something like that. So I'm just drawing additional lines. I don't need to draw so many lines, but north to south. Okay? That kind of makes sense? They kind of repel each other. These lines repel. Yeah, that's a better word. South-south repels, and you know this. And we have the north just working like normal. And over here, we'll be trying one of these questions. So, two identical bar magnets are there. At P, draw an arrow indicating the direction of the combined magnetic field of the bar magnets. Well, this one's going this way. This one's going this way. So at this part, yeah, imagine the effect on here. It would be like this. And this effect on P would be going down. So when you add them together, the effect on P would be this. So, yeah. That's the combined magnetic effect. Now, let's try this one. Two bar magnets replaced by weaker magnets. So these are weaker now. Two magnets are identical to each other. The magnitude of the magnetic field of a single bar magnet is this. So they're saying each of these are the same strength as the Earth's magnetic field. 1, 2, 3, all the same. Point B, draw an arrow indicating the direction of the combined magnetic fields of the bar magnet and Earth. Well, if they all have the same strength, that kind of means they all have the same length. Okay, this vector, this field strength is the length. Okay, so over here we know that's going in this direction. Yeah, because it's going out from the north, and over here the field would be pushing in this direction. So we have a sum of this one sending out something like in that direction, and it's that strong. We have this, and it's going this strong, and we have this one, and it's equally the same height. And we add all these things together, and then we realize that these two things cancel each other out, and all you're left with is this. So that's the combined effect. So that's just basics of magnetic fields. I'm going to go on to how electric currents create magnetic fields in the next video. Oh, wait, before I go, you should see this. This is so cool. Basically, I put two south poles, I put these two bits of metal to kind of stabilize it, and now I have my own little magnetic spring. How cool is that? So cool. I'm going to give it as a present to someone, and they're going to love it.